Every single morning, in every city in the world, a truck pulls up to the curb, swallows a bag of garbage, and drives away. You've seen it 1,000 times. The bag goes in the back. There's a loud mechanical groan, and that's it. Gone. But here's what nobody ever explains. What actually happens to that bag after it disappears? Because the answer is not what you think. Inside that unremarkable truck body is a hydraulic system so precisely engineered that it can compress the equivalent of a full studio apartment worth of trash into the size of a large refrigerator. And it does that over and over again on every single street, every single day, without anyone paying it the slightest bit of attention. By the time this video is over, you will never look at a garbage truck the same way again. If you want more engineering breakdowns like this one, hit subscribe and give this video a like. It helps more than you know. Let's start where the action actually begins, because most people think the important part of a garbage truck is the compactor. It isn't. The important part is what happens before the compactor ever touches anything. It's called the hopper, and it's the open loading bay you see at the rear of the truck. The hopper is not just an empty box. Its shape is a calculated engineering decision. The floor of the hopper is angled, usually at around 30 degrees, which is not random. That angle is specifically chosen to let gravity do the first stage of the work. When a bag lands in the hopper, the slope directs its weight forward and down, toward the opening that leads into the main body of the truck. The walls of the hopper are curved inward at the top, not for aesthetics, but to guide loose material back toward the center instead of spilling out over the sides. The entire geometry of that space is designed to funnel irregular, unpredictable loads into a consistent position before the mechanism activates. Most rear-loading trucks have a hopper capacity of around half a cubic yard. That sounds small, and it is. It's designed to be emptied on every single cycle, not to accumulate. The hopper is a staging area, not a storage area. Now this is where it starts to get interesting. Once the load is sitting in the hopper, the packer blade activates. And this is the part that almost everyone gets wrong when they try to explain it. The packer blade does not simply push straight forward like a piston pressing against a wall. It moves in an arc. Specifically, it follows a curved path that sweeps down from the top of the hopper opening, pushes the material forward and down simultaneously, and then drives it through the opening into the main storage body of the truck. That curved motion is doing two things at once. It's compressing the load as it moves, and it's also directing it. If the blade moved in a straight horizontal line, you'd get the garbage piling up at the opening and eventually jamming. The arc prevents that. It shepherds the material through the throat of the machine the same way you'd use a curved hand to scrape something off a table and into a drawer, rather than just pushing it flat. The packer blade itself is reinforced steel, often with hardened wear edges, and it spans the full internal width of the hopper, which is typically around 50 to 54 inches. There is no gap for material to escape around the sides. Every cycle is a complete sweep. But here's the part that most people never think about. The force behind that packer blade is not mechanical. There are no gears, no crankshafts, no chains. It's entirely hydraulic. And the pressure numbers involved are genuinely difficult to believe until you understand the engineering behind them. A standard rear-loading compactor operates at between 2,000 and 2,500 psi of hydraulic pressure. For reference, a typical car tire runs at around 35 psi. A pressure washer that strips paint off concrete runs at around 2,000 psi. The force being applied inside that truck body on every single cycle is comparable to a commercial pressure washer, applied not to a stream of water, but to a blade spanning the full width of the truck, pushing against everything in its path. That force doesn't come from a dedicated engine. It comes directly from the truck's own drivetrain through a system called a power takeoff, or a PTO. The PTO is essentially a mechanical tap into the truck's transmission that routes power to a hydraulic pump mounted on the engine. When the driver activates the compaction system, a portion of the engine's output is redirected from the wheels to the pump. The truck sits still, engine running, and uses that same engine that drives it down the road to power the most hydraulically demanding machine in the municipal vehicle fleet. I spent a morning at a waste management depot outside the city a few years back, talking to a maintenance supervisor while his crew prepped trucks for the morning routes. He showed me something that stuck with me. He put his hand flat against the truck body near the middle of the storage section, while the compactor was running on a stationary test cycle. The vibration was intense, almost violent, not in the cab, but in the body itself. He said most people think the cab drivers feel the compaction. They don't. The hydraulic system is isolated enough that the driver's experience is mostly just the sound. All that force is happening behind them, sealed inside the body, which is exactly how it's supposed to work. He also mentioned something I hadn't considered before: the hydraulic fluid temperature. On a long collection route in summer, the fluid can climb to near its operational limit. Some newer trucks have cooling systems for the hydraulic circuit specifically. In older equipment, a crew that's running fast on a hot day can actually trigger thermal relief valves that limit compaction force to protect the system, which means the truck is literally managing its own output to avoid overheating itself. And that's the system working perfectly. But here's where it gets genuinely strange. Because the system can handle heat, and it can handle pressure. But there's one category of load that behaves in a way nobody fully anticipates until they've seen it happen. Not everything that goes into a garbage truck behaves the same way under pressure. This is something the industry genuinely underestimates in public-facing explanations. Dense, rigid materials, things like hardwood furniture pieces, metal appliances, concrete rubble from home renovations, these don't compress. They transmit force back through the blade and into the hydraulic cylinder at full pressure. The system handles this by design. Modern compactor hydraulics include relief valves set at the maximum operating pressure, so when the blade encounters something it genuinely cannot move. The valve opens and bleeds pressure rather than destroying a cylinder rod. But there's a category of object that's worse than hard objects, and that's mixed loads with pockets of trapped air. A sealed plastic container, a thick plastic bag tied at the top, a gallon jug with its cap on. Under 2,000 psi. Those objects don't compress slowly. They fail suddenly. The pressure builds, and then the container ruptures. That sudden release is the bang you sometimes hear from the back of a truck mid-cycle. It's not mechanical failure. It's the hydraulic system winning against a pressurized container all at once. A well-maintained truck sees this dozens of times per day and handles it without incident because the system is built with exactly that kind of event in mind. Here's something that almost never comes up in engineering content about garbage trucks, and I think it deserves more attention. The compaction ratio. When people describe garbage trucks, they usually say something vague like, "It compresses the garbage." What that actually means, in measurable terms, is a volume reduction ratio of approximately 4:1. 1 cubic yard of loose residential waste, the kind that comes from households, gets compressed to approximately 1/4 of a cubic yard inside the truck body. A standard rear loader has a body volume of around 20 cubic yards. At a 4:1 ratio, that means the truck can hold the equivalent of 80 cubic yards of uncompressed residential waste before it needs to go to the transfer station or landfill. That's roughly the combined weekly trash output of between 400 and 500 average American households, in a single truck, on a single load. That ratio is not fixed, though. It depends entirely on what's being collected. Dense, wet food waste compresses very efficiently. Cardboard and paper compress well, but create more structural resistance than soft material. Foam, packing material, expanded polystyrene, these have a density so low that they compress, but also spring back partially when the blade retracts. Landscaping waste is arguably the worst. Irregular shapes, woody stems, high air content, poor compression. A truck running a pure yard waste route can see ratios closer to 2 to 1. Same machine, same pressure, very different result. Now, let me push back on something that gets repeated in almost every explanation of garbage trucks, because I think the consensus view is wrong. The conventional story is that rear-loading trucks are the workhorse standard, and side-loading automated trucks are the clear future, more efficient, cheaper to run, better for the crew. And that's partially true. But the argument ignores a fundamental engineering trade-off that cities keep learning the hard way. Automated side loaders use a robotic arm to grip a standardized bin, lift it, and dump it into a side hopper. The system is elegant and fast on the right route, but it requires every single bin to be standardized, correctly positioned at the curb, unobstructed, within a specific reach envelope, and capable of being gripped by the arm. In dense urban areas, in older neighborhoods, in places where infrastructure is irregular, the automated arm fails constantly. Not catastrophically, just operationally. It misses bins. It damages bins. It requires the driver to exit the cab anyway. The rear loader, which looks primitive by comparison, works on literally any load, in any position, placed anywhere near the truck. The packer doesn't care about the shape of the container. There's a reason rear loaders have not been replaced, despite being a decades-old design. It's not because municipalities are slow to adopt new technology. It's because the rear loader solves a problem that looks simple, but is actually deeply irregular. Automating irregular problems is hard. Engineers keep learning this. And that brings us to the moment that most people have no idea happens at all, which is also the most mechanically dramatic moment in the entire cycle of a garbage truck. Unloading. The assumption is that the truck tips at the landfill like a dump truck, the body tilts, and everything falls out. That's wrong for most rear loaders. They use an internal ejector panel. The ejector panel is a full-width, full-height steel plate that lives at the front of the storage body, immediately behind the cab. Throughout the collection route, as the packer pushes load after load backward from the hopper, the ejector panel is what that compacted material presses against from the front. The entire load builds up between the packer side and the ejector side. When the truck reaches the tipping floor, the tailgate swings open, and then the ejector panel is driven forward by its own dedicated hydraulic cylinder, pushing the entire compacted load out through the open rear of the truck in one continuous movement. The ejector panel does not move fast. It moves slowly, deliberately, under enormous pressure, pushing what can be 8 or 9 tons of compacted waste as a single mass. This is the moment of maximum structural stress in the entire operating cycle of the truck. More than any compaction cycle, more than any road load, the chassis is absorbing a longitudinal force as the ejector pushes forward and the truck body pushes back, and the load transitions from static friction to moving mass all at once. Truck bodies rated for this are engineered with reinforced floor channels, side rails with specific yield characteristics, and tailgate hinges overbuilt to a safety factor that would seem excessive until you watch a full ejector cycle on a heavy load. The body is not just a box. It's a pressure vessel designed for directional force, and the ejector cycle is what it was actually built for. What you've just understood is something most people spend their entire lives never thinking about. A garbage truck is not a container with a crusher. It's a mobile hydraulic system that stages, compresses, accumulates, and ejects solid waste in a continuous engineered cycle, powered by its own drivetrain, managed by pressure valves and relief systems, and optimized for a compaction ratio that makes the math of urban waste collection actually work. Every bag you've ever put on the curb has gone through a machine that applies more pressure than a commercial pressure washer, stores the result against a steel plate, the weight of a small car, and eventually pushes it out as a single compressed block onto a tipping floor. 400 households per load, every morning, in every city, without anyone watching. Now you're watching. If this kind of engineering breakdown is what you come here for, drop a comment below with the machine you want explained next. And the next video is already on screen, right now.